Here's some more examples on the transformations of trig functions. So this is the second part of the 5.3 video. Okay, so what we have here is an example where we're not actually graphing anymore. We're analyzing all of these different functions, but within a table. Okay, so here are four examples. And I'm looking at the examples and I can already recognize that this guy right here will probably be the one that's a trick question where you have to factor out that k value. So this 4 is your k value and it looks like this is my d value, but it really isn't because we have to divide it by the 4 first, factor it out, and it'll look nicely like this. So the negative pi becomes negative pi over 4 because I've divided it by 4. And now this is the form that I want each of these guys to look like because I can easily see what your a value is, your k, your d, and your c, and then I'll be able to answer any of these questions. Okay, now taking a look at any of the other examples, you should have a set of square brackets and a set of round brackets. Okay, now some of them don't, and then we really have to use our imagination as to how to recognize where they are. Okay, so notice that your cos, right after it is where your square bracket should be. So that's the same with any of these guys. Okay, so let me put in the first square bracket. I guess I kind of cut it off a little bit, but anyways, if you can recognize your c value, it never has a bracket behind it. So the other square bracket goes in front of that c value. So here's your c value. I'm going to put that other square bracket right here. Okay, the c value doesn't really exist here. There's no number. Okay, so I'm just going to put like it's a 0. So there's my other square bracket. And this is our c value. So I'm just going to put the other square bracket right here. It's a little bit hard to write with a mouse, but you get the idea. Now your round brackets, the first round bracket goes in front of the x. Okay, so here's the x, and you already saw the round brackets right there. Here's your x, there's the round bracket right there. Here's the x, and then the round bracket's right here. So whatever's in front of that round bracket, this is your k value. Okay, so there's your 3, and this one's k value is a 1 because you don't see anything, and this one is that 4. Okay, now the other round bracket goes behind the number that follows the x if there is one right here. Okay, so round bracket goes right after the pi and after this negative 2 pi, and then this round bracket, since there is no number, it goes right after the x. Okay, now that you see all of those, you can recognize your a values, k's, c's, and d's. All right, now remember, use your imagination because when I go on to the next slide, all these brackets are going to disappear. Okay. All right, your amplitude. Amplitude is very easy to recognize. It is just your a values. Okay. Now be careful because it's just the a value. It is not that negative that goes with the a value. It is very similar to your vertical stretch or compression. So in this case, it would be a vertical stretch by a factor of 2, not negative 2. That's why we write 2. Okay, now that negative shows up when you talk about your reflection. So in this case, yes, we do have a vertical reflection over the x-axis. The other ones don't have a negative in front of the a values and therefore don't have this kind of reflection. They could potentially have a horizontal reflection if there is a negative in front of the k value, but as you can see, none of these guys have a negative in front of the k value, so this still stands true. All right. Your period is what you could analyze next. Now we know the equation that the period is equal to 360 degrees, except it's changed to radians, divided by your k value. Okay, so we could always calculate the period or the amount of, I guess, time or the width until you have the end of one cycle. Okay, so you take 2 pi divided by your k value, and then you get your period. So 2 pi divided by half is 4 pi. This should make sense to you because 2 pi is 360 degrees, right? Well, now it's doubled in length to 4 pi, which is 720 degrees. It should make sense because isn't this a horizontal stretch by a factor of 2? So now you've taken your graph and you've actually stretched it twice as wide as it was before, which makes sense because now instead of 2 pi, it's 4 pi. All right. So the vertical shifts, and this one, phase shifts, remember, is just a horizontal shift. Comes with this blue and green that I've highlighted. Okay, so I have the greens right here. This is a down 3, so any of the greens, this one doesn't have a C value, so I just put none. Okay, and this one is a positive 2, which means it's going to be up 2, and those are just how your graph is shifting up and down. Okay, the phase shift is this highlighted blue, cyan, I don't know how to, blue, whatever. Remember, this is going to be the opposite of what you think as well. So instead of going left 2 pi, you're actually going right 2 pi. Okay, and this one's going to be left pi. Okay, now in the previous video we did discuss how we could graph it if we weren't using mapping notation. So the video had shown mapping notation, but the other way is you could always graph all of these separate transformations. It's just a lot of work. The way that you'd want to do it is you'd want to graph any of the stretches and compressions first and also the reflections before you do any of this stuff to it. Okay, so any of the movements you want to do last. Okay, this is a very good question to put on a test. This is where you're given a graph and you actually have to figure out the equation of the graph. Now the equation could be in sine or cos. You might actually have to provide both. So I'm going to show you how to do both. It's really important to know where your peaks are first. So your max in this case is 4 and then the min is at -4. It's also very important to figure out one cycle. So I just chose a starting point and then mapped out one cycle before it started to repeat itself again. Okay, so this green will really tell me about my amplitude, which will indicate something about my A value. And this part right here, one cycle, will tell me about my period, which will lead to my K value. So with your A value and your K value, you then have pieces of information towards your equation. Okay, so let's start calculating. Now I noticed that from 0 to 2 pi over 3, that's going to be my period. I'm going to use the equation, period equals 2 pi over k, and I'm going to put that 2 pi over 3 right here. Okay, so that's where I got this guy from. This is just the rest of the equation that I just wrote down, and I'm going to calculate what k is. So cross multiply, 2 pi times k is 2 pi k, equals to 3 times 2 pi, which is 6 pi. Okay, so in order to get k by itself, I'm going to divide this 2 pi out. So I'm going to cancel it out on the bottom, which means I have to do it over here as well. Okay, so 6 pi is going to be divided by 2 pi. The pi's cancel out and 6 over 2 is just 3. This number is going to go into that k value slot in my equations. Okay, so the amplitude. Equation for the amplitude is taking your max minus your min, getting that answer, and then dividing it by 2. So I've shown my work right here. This is going to help us out with our A value. All right. Now here's where it gets a little bit tricky. Again, I could do cos or sine. I can use either. And most likely one of your test questions will probably tell you to do a specific one or show that you know how to do both. Okay, so what I've done is I've just mapped out one cycle of a cosine. So a cosine should usually have this type of shape, and a sine. So I've started the sine right here and I've mapped out one cycle of a sine. Now the sine could have started over here. It really doesn't matter. In fact, your cosine, if you wanted to, you could have mapped it out starting over here. That's okay too. Okay, so as you can kind of start to figure out, like there should be, or there could be, infinite number of answers for a question like this. Okay, so here are two of my answers, one cos and one sine. The amplitude for both the sine and the cos, so I already wrote the cos and the sine here, the amplitude does not change for either of them. They're both exactly the same, and the K value is exactly the same. Now let's start to talk about the C values. For both of them, they should have the same C value, and I know that it's 0. One easy way to calculate that is if you take your maximum number, your 4, minus your amplitude, that will give you your vertical shift. Okay, or you can think about it logically and say, well, you know what, if my max is 4 and my min is -4, that's what it normally should look like if I've stretched it by a factor of 4, so it has not shifted up or down. It's at positive and -4, which is straight kind of in the middle. All right, so it should be the same for both. Now in terms of the phase shift, the coast one does not have a phase shift because coast normally would have started at this position where the top of the coast graph is along the y-axis. Okay, the sine graph, however, has shifted. Sine normally should start at 0, 0, but notice that the one that I chose started all the way over here. So I need to indicate that this sine graph has started pi over 2 to the right, and I've indicated that right here with the minus sign because it's the opposite of what we normally write if it's inside the brackets. Okay, now how did I get the pi over 2? I actually just counted the scale. All right, so I know that's a little bit tricky, but it will really help us in the very last example, which is a word problem. Okay, so this is a good word problem. What I'm going to do is I'm just going to scroll down. This is the last example. Okay, so we have a pendulum that swings back and forth 6 times in 12 seconds. It swings through a horizontal distance of 30 centimeters. So first of all, we want to make a sketch of the motion for 3 cycles, and this is important, beginning with the pendulum at the center of its swing. So at the very beginning, that's the center of its swing, and it's going to swing almost imagine someone standing on a chair facing this way, and they're going to start swinging this pendulum left and right, and left and right, left and right. So there's my 3 cycles. You know that 12 seconds will give you 6 swings. Okay, so if I divide those, I'll get my period. That means that there should be 2 seconds for 1 swing. Okay. All right, so that's my period right there. It's going to help me calculate my K value for my equation, because the second problem actually asks us to create the equation for this situation. All right, so if I take the period of 2, I'm going to put it into the equation, and 2 is equal to 2 pi over k. Cross multiply and solve, and you'll get k equals to pi. So this number is the one that's going to go into our K value. Now they also told you that the horizontal distance is 30 centimeters. That means if I'm swinging from the left to the right, this total distance is going to be 30, and that's why I chose 15 and -15. Now you could have always have shifted this entire graph up if you wanted to and started at something higher to something over here, but I mean, I figured it was probably easiest to just go positive negative of the same number and then just divide 30 by 2. So you have a total distance of 30 right here, 15 on each side. That gives you an amplitude of 15. All right. Again, there is no C value because normally a sine graph, which is what I chose, it didn't ask me to use a sine graph, but I figured it kind of looked like a sine graph. So I mapped a sine graph on top of this, this diagram that we saw. And I mean, the sine normally starts right at 0, 0. It didn't shift up, or else it would have looked like this. Okay, so because it started right at 0, 0, there was no vertical shift, and that's why I put a 0 here. Also, because it started at 0, 0, I didn't shift it left or right. So I don't have a phase shift in there either. Okay, I could have mapped out a cos equation, which totally would have been legit as well, but it seemed like it was a little bit more difficult because a cos starts at a peak and then goes down and goes up again. So this one would have required a more complicated equation because it also would have included a phase shift in there.